All right, let's do an assessment. So, what do we have here? Two questions. Can you do a binary tree? Return the sum of all the left leaves. A leaf is a node with no children. A left leaf is a leaf that is the left child of another node. So this is the tree. There are two left leaves in the binary tree with 9 and 15. This is a leaf. This is a leaf. Leaf is a node with no children. Fair. Left leaf is a leaf that is a left child of another node. Node which has no children and is a left child. Okay. Can we do pre-order traversal? So from pre-traversal you go to 3. 3 has a left child. So it's not okay. Let's try. Let's try very basic. So sum of left leaves. I mean, one idea is obviously to start with equals to 0 and just keep doing traverse. And you can say if it's left or not by returning false, saying false. So um, okay, so you do void traverse, so you know root boolean is left child. Okay, so now if root dot, first of all, can root be null? If root equals to null, just return. If root dot left equals to null and root dot right is equals to null and is left child, sum plus equals to root dot data. And do you want to return or do you want to go somewhere from this point? I think you can return also, right? Just return. And if, yeah, I mean, traverse root dot left fall, okay, true. Traverse dot right, true. And in case it happens multiple times, let's also make sum equals to 0 here. After traversing, return sum. Sure, that's on code. Okay, it's not called data, it's called val. Hmm, 31, and the answer is wrong. Let's see what are the roots you consider. So, uh, this is the one that you considered. So you considered 9, 15, and 7. Why did you consider 7? Because you missed it here. Uh, Sprint, run again. So 24 is correct. Let's run example test cases. 24 and 0 are correct. Submit. All right. Going to the second question. You are given an integer array cost where cost of I is the cost of ith step on a staircase. Once you pay the cost, you can either climb one or two steps. You can either start from the step with index 0 or the step with the index 1. Return the minimum cost to reach the top of the floor. Sort of DP, sort of Fibonacci. Yeah, okay. Let's see. So most climbing stairs. You pay the cost and then you move either one step or two steps. So here you start at index 1. How will you start at index 1? You can either start at index 0 or step in, or the step index. Okay, you can start at 0 or 1. And every time you have two options. At 15, then you take, okay, you start with index 1, pay 15 and climb two steps to reach the top. Okay, fair. You will start at index 0, pay 1, climb two steps to reach pay 1, takes two steps to reach here, pay 1, two steps to reach here, pay 1, two steps to reach here, pay 1, take a single step. Yeah, that's completely fine. So let's write it recursive. Let's apply DP and then we'll see if we can do it bottom up. So first write recursive, right? So basically, something you want to do is this. So you want to return not.min climb root 0, climb not root the cost. You start at either at index 0 or you start at index 1. So this is where you are, and so you go int climb so you go cost and you go what index, and which index do you want to reach? If your if the index that you are at is cost.length or greater than equal to cost.length, what that means is you have climbed all the stairs, and then you want to return something. What do you want to return? 0, I guess. There's no further cost associated. Otherwise, so you're at index I, you have to pay that cost. That's for sure. Then you want to do return math.min of cost of index. Okay, so you do return cost of index plus math.min of climb math.min climb cost index plus 1 or climb cost index plus 2, right? That is it. So uh, let's first try to see if it solves for these two, and then we'll try to optimize. Definitely optimization is needed. So first of all, your answer itself is wrong. You took 35, even though you needed min. 35 means you added this regardless. So you can start at 10, you can start at 15, right? So you did this. So let's see what this will do. So is this the case? Index equal to greater than equal to cost of length? No. So you return cost of index, which is 15 plus math.min climb of 2 and climb of 4. So climb of 2 will return 20, which is fine, but climb of, okay, missed this typo, okay. Index plus 1 and index plus 2. So yeah, so you got 15. Let's look for that one, which is 6. So you're solving it. Now let's optimize it. So let's first use TP. So basically you want to solve for climb at every index. So you do integer array TP equals to, is the cost negative anywhere? No, right? So you get your DP array. Now this is fair. If DP of index is not equals to -1, return DP of index, and yeah, let's run again. And yes, you do get 15 and 6 again. Now I want to see if I can do it top to bottom. So let's keep this handy for ourselves. In fact, let's just keep this function handy for ourselves. And let's keep this handy as well. Now let's see what we can do from top to bottom. So from top to bottom, the bit is let's go from right to left. So for I equals to cost of length minus 1 and minus minus. I mean, one bit is clear. For every node, it will have its own cost, right? So you can do for int I equals for each. So yeah, for int I equals to 0, I is less than cost of length. I plus plus, you can say, you can initialize dp of I as cost of I. Now what you want to do is go from right to left. So for int I equals to, maybe I don't need that, but I'll see. So cost dot length minus 1, I is greater than equals to 0, I minus minus. So really what's happening is this dp of I equals to, okay, let's get rid of this for our time wheel. So dp of I equals to cost of I plus math dot min of dp of I plus 1 and dp of I plus 2. So now we do this. If I equals to I mean, it's sort of clear that for the last two guys, the cost is themselves, right? You start from cost at length minus 3 directly. You could do that. You could do something like this. And you want to return math.min dp of 0 and dp of 1. Okay, run code. Here you get 15. An example test cases 15 and 6. Now I'm even wondering, because I only need two things at any point in time. So do I even need this array? Optimize it further and let's do one step and two step, right? So int so for example, for this guy, one step was this and two step was this. So one step is actually just take the cost of cost dot length minus 2, and then two step is cost of First dot length minus 1. Now I wanna do start from this. What is the minimum size of the array? At least 2, right? Yeah, so at least 2, so these 2 will get covered. Then if this will not happen, then you'll return math.main one step comma 2 step, and you do now you keep changing, right? So for this guy, if I take one step, interesting. For the if I so no, not math.main. So one step equals to cost of I plus one step, and so basically what you're saying is one step plus equals to cost of I. Two step plus equals to cost of I. I'm feeling something wrong here. Because everyone, if you reach this guy, if you reach this guy, then the cost is this. If you reach this guy, then the cost is that. Okay. So yeah, this is A and B, basically 0 and 1. You know, return 0 and 1. So now from this guy, you can go to this or this. That means the cost here would be this, correct? Hmm. Something is fishy. Uh, let me see. So you either take one step or you'll take two step, right? So basically, I understand that cost will be It can be solved, man. You're just not taking it seriously. Like for example, for zero, it is cost of zero plus cost of one or cost of two. Similarly, at one, it's one plus two and three. Okay, so let's do this. So for I, you need I plus one or I plus two. So let's do zero and one, right? Come on, yeah. So zero, you need one and two. For one, you need two and three. Okay, shooting with one by one. Fair. So these and this. I got it now. I got it now. So A is of the next guy and B is of the second next guy, right? A is the next guy and B is the second next guy, right? So A, for me, what will change? So B will become A and A will become something else. For example, if you have 0, 1, 2, 3, you have 0, 1, 2, 3. Right now, this is A and this is B. And you want them to shift. You want this to happen. So both are changing, right? So A is just becoming B. No, B is just becoming A. What's happening, man? Yeah, so whatever A is, that B becomes A. And you want to find new A. So new A equals cost of I plus math dot main of A comma B. B equals to A equals to new A. Okay, let's run example test cases. 15 and 6. All right, submit. And you've done. Okay, both were easy, it seems. Let's see if this guy is covered. This guy has a solution. It doesn't have. Let's see our submission. What does this guy do? Yeah, you can save the space. Let's look at the space, not the time. Time is pretty much same. Yeah, so let's look at what this guy is doing. First is cost of 0, second is cost of 1, answer equals to 0, I equals to greater than I plus plus. Answer equals to cost of I plus first dot second. First equals to second, second equals to answer, and first 1 second. You're doing from right to left, he's going from left to right. Either of these two costs will be calculated, which is fair. For third guy, so the third guy, whatever you calculate, will be the second. Yeah, the first will become second, correct. And we keep doing that till n or n minus 1. So yeah, fair, sort of similar. And it still doesn't get that much higher of a score. Alright.